Well, good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Prakar, and we're going to go over 6-6 and behaviors. So to start out with, you're going to need Desmos. You can see I got Desmos on the right-hand side here, so go ahead and open that up. But I just want to talk a little bit about graphs and what end behaviors are a little bit before we kind of get into this. So I'm just going to throw a graph up here, and we'll look at this like this. End behaviors, what are they? End behaviors are where your graph is starting and kind of going, ending. This is where my graph starts because if you cut this in half, it's on the left-hand side. It's coming from the left. So this is where my graph starts. Okay, and if you look at it, it says, well, how does it start, positive or negative? Well, it's going down here, so that means it starts negative. This is my ending side. This is the end or end behavior. And that's on the right-hand side. It's where your graph is going as x is approaching positive infinity. Okay, it's going to the right. Well, it's ending, it's going up, so it ends positive. So this graph starts negative, but it ends positive. Another one, we'll do one in blue here so you can kind of get an idea of it. Just a parabola that opens up like this. Well, it starts on this side and it ends on the right-hand side. So what is it doing? Well, it starts, it's going up. This graph is going up, so it starts positive. And it ends on the right-hand side as it's going to positive infinity. X keeps getting bigger and bigger, positive to the right-hand side. So it ends positive. This one starts positive and ends positive. If you looked at this one, it starts negative and it ends negative. Okay, so that's one that we're talking about, starts and ends. It starts on the left-hand side, it ends on the right-hand side, just so you guys kind of know what's going on there. So we're going to get rid of that, and we'll jump kind of right into this. Actually, I'm going to do one more, but I'm going to type something into Desmos here. Here's a function I want to look at a little bit and talk about how it starts and ends with you guys, and then talk about its degree a little bit and its leading coefficient. Typing this in, you don't have to type this in, you can just follow along. This is 3x to the fourth minus 7x squared. Yep. And plus x. And what else do we got here? Minus 2. Okay. So here's my function. Okay, we typed it in there. You can see it. How does this start and end, first of all? Well, you can see on the left-hand side it's going up. If I drew a little picture of this, it kind of looks like this. Oops, let me try that again. Kind of looks like this, and I'll put the little arrows on the ends because that's where it would be up on top there. How does this start and end? What are my end behaviors, I guess you'd say? Well, if you look at the left-hand side, it's going up. So it starts positive because it's going up. And on the right-hand side, what is it doing? Well, it ends positive, okay? And you'll see that both my end behaviors, my start and my end, are both going up in this case. They're going in the same direction. And that's kind of because of the degree. So what is the degree of this? Well, the leading term is 3x to the fourth. 4 is the highest power. So this is a degree of 4, and that is an even number. There's a difference between odd and even degrees. If it's an even degree, you're going to see that the end behaviors are always going to go in the same direction. It's going to start and end the same way. If this would have been an odd degree, like 3 or 5, the graph might look something like this. This would be an odd degree. The start and the ends are going in opposite directions, and that's for odd degrees, okay, like 3, 5, 7, whatever. We also talk about leading coefficient. Now, that's the number in front of, now this is degree 4, that's my highest power. So this is my leading term. So my leading coefficient, we'll abbreviate coefficient in this case, is 3. That's just the number in front of your variable term that is your leading degree, leading power, whatever you want to call it. So degree of 4, that's even, and its leading coefficient is 3. And you can see that where we typed in 3x to the 4th. 4 is the highest degree, so it has a power of 4. It's an even degree. And you can see how it starts and ends, okay? So that's a little bit with leading coefficient, degree, all this stuff. And we're going to do some work with this and practice this a little bit. I think I'm going to do 3 or 4 problems with you guys, and then I'll let you kind of finish it up. But now we'll kind of jump into it. Okay, let's pull this worksheet back up here. And I'm going to scoot this over a little bit. Now you can see we got A, B, C all the way through I. We got A through I. And they match up with one of these graphs down here. There's basically 9 functions, and there's 9 graphs, and we're going to match them up and kind of talk about them a little bit. So the first one we're going to look at is A. So we're going to go over here, exit this out, and we're going to type in A. Now they got y equals, you don't have to put the y equals, but I will, y equals negative 2x squared plus 3. So I'm going to say negative 2x squared, hit the a squared button, and then plus 3. And there's my graph right there. So I got to look and find one that it matches up with here. And it looks like it's this one right here, the one in the bottom right-hand corner, okay? First of all, the equation letter, well, that was A. So I'm going to put an A here. If you go back up here, you can see that that was A. Y equals negative 2x squared plus 3. That's what we got plugged in there. That matched up with this one. What's the degree? Well, it's x squared, so the degree is actually 2. And so we're going to put right 2 in there. But I want you to also write this, even. Even degrees are different than odd degrees. Those graphs, there's 2 different things about them. So I want to talk about that. My leading coefficient, well, the number in front of the x squared is negative 2. So that's negative 2. And I want you to write negative there also, because if you can see, this starts and ends, being it's even, they're both, the end behaviors, the start and the end, are going to go in the same direction. And they both are going down. And that's because it's a negative 2 right there. If it would have been a positive 2, they would both be going up. Your leading coefficient kind of decides this. Well, how does it start? Well, here's the start right here. It's always on the left-hand side, and that's going down, so that's negative. And how does it end? Well, here's my end right here, and it ends negative also. That's because of the leading coefficient was negative. They're both going in the same direction. Okay, so that's what I want you guys to be able to do with this. So let's do another one here. I'm going to kind of take this on here. Let's get rid of this. Okay. Okay. B. If we type in B, you can just exit it out like that. I'm not going to type in the y equals this time. I'm just going to jump right into the function, and you can do it that way. That's fine. 2x cubed. So I'm going to hit 2x, and to get the x cubed, you got to hit the A, B button here on the right, and then hit 3. Plus 3x squared, so plus 3, hit the x button. You can do the A, B button again. In fact, I will, but I got to hit 2 now. So I got to hit the 2, so it's squared. Minus 7x, and then finally minus 4. Whoops, I did that wrong. Minus 4. There it is. So let's move this down a little bit here. There's my graph. I got to find one here The top three, it doesn't look like any of those. Doesn't look like any of the middle three. You know what it kind of looks like? Why wouldn't that stay? Let's get rid of this now. Sorry. It kind of looks like, to me, it looks like this bottom left one. So let's open that up a little bit. Yeah, this one right here. Starts and negative and ends positive, kind of like our graph in green there. Starts negative, ends positive. This was graph B, so let's put B here. The degree, well, the highest power there is the x cubed, so that's a degree of 3, and that is odd. And I want you to notice it starts negative and ends positive. It's going in opposite directions. Whenever it's an odd degree, this is what your graph is going to look like. It's going to be the start and end go in opposite directions. Leading coefficient, well, 2x cubed is the first term, but it's the highest power, so that's my leading term. So my leading coefficient is 2, and that's positive, okay? Make sure you know that that's positive. There's a reason for that. It starts negative right here, and it ends positive right there. The leading coefficient was positive, and here's the deal with that. No matter if it's odd or even, okay, the leading coefficient, if it's positive or negative, tells you how it's going to end, okay? This end's going up because this was a positive 2. If that would have been a negative 2, you'd flip this whole thing. It would start positive and then end negative. So just so you kind of know what's going on there. Okay, so we're going to shrink this down. Oh, I wish that would stay, but it doesn't. So I got to get rid of it. Okay. And we're going to go to the third one here. Now, third one. Now we got some decimals here. So let's exit this out. 0.25 x to the fourth. So 0.25, whoops. X to the, hit the AB button and then hit 4. And then minus 2x squared. Minus 2x squared. Right there. Okay, it's a W. There's a couple W's here. It goes through 0, the 0.00, and this, so I'm looking at this middle one right in the middle, or this one to the right, and I think it's the one top right one, because it goes through 0, 0, and then it kind of crosses. It goes down to 4 for the two low points, but it crosses at just before 3 and just before negative 3. So here's my graph, and I think that's it. This is from C. So the first thing I'm going to write here is this is C. The degree, well, x to the fourth is the largest power there, so it has a degree of 4. And that is even. If you notice, it's even. My end behaviors, it starts and ends. They're both going in the same direction, up. Leading coefficient is 0.25, and that's positive 0.25. So it needs to end positive, and you can see, oh, I'm sorry, positive. You can see it, and this is the ending side on the right, and this is the starting side on the left. It starts positive and ends positive. That's because it's even. If it's even, they're always going to go, the start and end are always going to go in the same direction. If it's odd, they go in opposite directions. But because it's a positive 0.25, it ends positive, okay? The leading coefficient always tells you where that it's going to end. It's going to end positive or negative. And if it's positive, it's going to end positive. But because it's even, okay, they both go in the same direction, the start and the end, okay? Okay, so, oh, it stayed with it that time, good. Let's do one more, and then I'll kind of let you guys work on them. Let's go to D here. That's negative 4 x cubed. Hit the AB button to get that 3 in there. plus 6x squared plus x and minus 4. Oops, there we go. Okay, which one does it kind of look like here? I would say doesn't look like any of the top three, doesn't look like any of the middle three. I tell you what, it does look like this one right here. I think it crosses, yeah. It goes up and down. That's good. This was D, so I'll put a D right here. That was letter D. The degree, well, the highest degree is x cubed, so the degree is 3, and that is odd. And it starts and ends in different directions, and that's the deal with an odd degree. The leading coefficient is -4, okay? And that is negative, so I'm gonna put a little negative there. That tells me it should end negative. And if you look right here, it ends on the right-hand side. Here's where it ends, okay, and it's negative, it's going down. But because it's odd, it starts in a different direction. It starts on the positive side here. So it starts positive. And that's kind of how these functions work. You can tell a lot by that leading term, -4x cubed. This is the degree, okay? It's the largest power, and in this case, the largest power is 3. And this is my leading coefficient right here. And that -4 tells us how it ends, okay? So there's a lot you can learn just by looking at that first term, or the term with the highest degree, highest power. Okay, so I'm gonna let you finish this up, but I think I do want to look at the back with you guys and kind of fill this in, because I did this with my other classes too. So I kind of want to do it with you guys. What patterns do you notice? What does it say for number 1 here? What patterns do you notice between the degree of the polynomial and where the graph starts and ends? If the degree is even, so let's put that first, right here. If the degree is even, okay? Then the graph starts and ends in the same direction. In the same direction. That's the key. The graph starts and ends in the same direction. Okay? Kind of like this. If it's a degree of 4, right? It's kind of going to look like this. Let's say it's a positive leading coefficient. It would go down 1, up 2, down 3, up 4. You can see, oops, that they're both going up. If it was a negative degree 4, it would look like this. It'd start negative, down, up, down. They would both be going down. Just like if it's a degree of 2, it's a parabola. They're either both going up or they're both going down. Even degree, it starts and ends in the same direction. That's kind of the main thing there. If degree, excuse me, is odd, if degree is odd, then graph starts and ends in opposite directions. Sorry if that's so messy, but I said it anyway. It's hard to write for me sometimes here. I gotta write directions again, that's terrible. Opposite directions. Okay? So that would be something like this. If it was a degree of 3. Well, it might start negative, go up, and then down, and then back up. That's 3 different directions. It would start negative and end positive, or start positive and end negative. It's always going to be in opposite directions if it's an odd degree, just so you guys kind of know that. And I want you to have that in there because that's one of the things you need to get out of this section. Okay? Okay. So number 2 here, and then I'll let you guys work on this. What patterns do you notice? What patterns do you notice between the leading coefficient of the polynomial and where the graph starts and ends? Here's the deal. If the leading coefficient is positive, is positive. The graph is going to end positive. Ends positive. It's always about the ending with the leading coefficient. Let's go blue here. If the leading coefficient I'll abbreviate that, is negative. Okay? The graph ends negative. We'll abbreviate that too. So I don't care if it's like negative 3x to the 5th, we'll say. That graph would be something like this, down 1, 2, 3, 4, 5. It'll start positive, but it ends, now it's an odd degree, right? So they're gonna start and end in opposite directions, but because the leading coefficient, the leading number in front of this variable term, leading term, is negative, it's gonna end negative. But if this was a positive 3x to the 5th, then it would start like this, 1, 2, 3, 4, 5. It would start negative, but end positive because it's a positive coefficient. That leading coefficient is going to tell you how it ends for sure, whether it's even or an odd degree, it doesn't really matter, but it will end in that same direction, okay? Not necessarily start in the same direction, but end in the same direction. And that's all I really have for you for 6-6. If you do have any questions, you can email me a question or you can sign up for some office hours and we can go over this a little bit if you need it. Other than that, I'm going to let you go. Have a great day.